I talked earlier about agricultural terraces, and agricultural terraces are a way of reshaping rural landscape. And in reshaping the rural landscape, we take a continuous hill slope and we transform it into a series of terraces. And we can see this area that's been freshly plowed, and we can see a small hill running parallel to the contour, running across the slope, and another small hill here. And what those hills do is they create more level planting surfaces in between the two hills. And with the level planting surfaces, then we are reducing runoff, we're reducing the rate of runoff, and thereby we're promoting greater infiltration because the runoff is going to hang around longer in the landscape. So we are promoting infiltration, we are promoting retention of stormwater in the landscape, in this case in an agricultural context. And we can see that then planted where we begin to see the terraces, the benches in between the terraces of the landscape planted in a perennial cover that helps to reduce the amount of erosion that's going to occur on these slightly steeper landscapes. So agricultural terraces become another strategy of trying to promote infiltration of water into the landscape, reduction of surface runoff, and improvement of water quality. We can see in especially the bottom slide, but also the top slides, the concept of contour strip cropping, where instead of running the rows of crops straight up and down slope, we're running the rows of crops parallel to the slope of the landscape. And we can see these crops of corn, these rows of corn bending as they move through the landscape because the slope is going down this way. And so these strips of corn are being grown interspersed with strips of, say, alfalfa or other cover crops that promote infiltration of water. So we get a mixture of food-producing landscape with landscape that is promoting water retention in the landscape and mitigation of water quality. We can see what that looks like in the larger landscape where, in this case, a farmer or a couple or three farmers have gone together and organized a landscape that provides these multifunctional values that I spoke of. We can see here in this landscape, the channel has been squared off, the buffer strip has been squared off to make it possible to farm in a more efficient manner. The edges of the buffer strip don't matter that much in terms of water quality and water retention, and the geometric shape that we see here would work as well as a more biomorphic shape as well. So we can see then the composite of these different systems being integrated into the landscape. Here we see a drainage ditch with a series of check dams in it, and the check dams slow down the rate of discharge, help retain water behind each of the check dams, and then we have a grassed filter strip planted along the side of the ditch. Finally, we can talk about something called controlled drainage. In agricultural areas throughout much of Minnesota, the soil holds water for a long period of time, and it makes it more difficult to farm in an economically efficient manner. So as a result, in low-lying areas, we often have what are called drainage systems, which are a series of underlying pipes, perforated pipes that draw water out of the soil and transport it to a drainage device. And the design of this drainage device can be used quite strategically to moderate the amount of surface and subsurface flow coming out of the agricultural landscape. by using a series of valves and stop blocks, we can actually regulate how much of the soil moisture is going to be discharged at any one point in time. And by manipulation of the surface drains and surface grading, we can regulate the amount of surface runoff that's flowing. So with these control drainage systems, we have the capacity, not only through management of the surface of the landscape, to reduce the amount of runoff that's being generated from the landscape, but also by managing the subsurface drainage system to also reduce the amount of total runoff. Finally, the last point that I want to talk about is the notion of taking this drainage runoff, the water that's captured by subsurface drainage systems, and in certain kinds of landscapes, infiltrating that water into deep storage. That necessitates a strong concern to deal with the quality of that subsurface storm flow coming off of an agricultural field. But in the context of these drainage systems, we can talk about how do we go about treating the quality of that runoff before it is injected into the underlying material.